Here we're given the length of two legs of a right triangle and asked to use that to find the length of the hypotenuse. So our first step is to sketch our triangle and label the sides. If we look over here in the top right, we can see that the legs are the sides that form our right angle. So this is a leg and this is a leg, because together they form this right angle. So this is true however our right triangle is positioned. So for my triangle over here on the left, this would be a leg and this would be a leg because they form this right angle. So let's label those sides 9 and the square root of 15. Then the hypotenuse is always the side that is the longest, and it's the one that is across from a right angle. So I think of this right angle as pointing towards our hypotenuse. So this is our hypotenuse right here. Now, when you know two sides of a right triangle and you're asked to find the third side, you can always use the Pythagorean theorem to find the length of that missing third side. So we need to know what A, B, and C are. A and B are always the legs. It doesn't matter which one you decide is A, which one you decide is B. So let's call this one A and this one B. The hypotenuse, though, is always going to be our C. So let's substitute these values into the formula. Once you do that, you can begin to simplify. So over on the left, if you put the square root of 15 squared into your calculator, you're going to see that that's just 15. And that's because the square root and squaring are inverses. They're opposites. They cancel each other out. But 9 squared is 81. So all that equals C squared. Now we can add 15 and 81, and we get 96 equals C squared. At this point, we can undo the square. Remember, the inverse of square, the opposite, is square root. That will cancel this out. So let's take the square root of the left side as well. Now, we could put the square root of 96 into our calculator. We'll get a decimal. If we want to instead simplify, we can do that. Because when you change it to a decimal, then you're rounding. You're not giving the most exact answer. So 96, square root of 96, what we need to do is break 96 down into factors because we want to see if there's anything that's being squared that we can pull out from under the square root symbol. Now, in order to break down 96, you could test out some bigger numbers, or if you happen to know two numbers that multiply to be 96, that's great. If not, you can just start off with the smallest prime number, like 2, and say this is even, so I know I can divide this by 2. If I divide 96 by 2, then I get 48. And then once you have a prime number, I always circle that. And then 48 is the same as 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And then 6 is 2 times 3. So square root of 96 is the same as 2 times 2 times 2 times 2 times 2 times 3. Now you can ask yourself, what is being squared? What are there 2 of? Well, there's 2 2's, so I can pull that out. Here's another 2 2's, that's being squared, so I can pull out another 2. But nothing else is being squared. So this 2 times 3 needs to stay underneath the square root symbol. So that's 6. So when I simplify, I pulled out 2 times 2, which is 4, and I had to leave in a 6. So the length of our hypotenuse is 4 square root of 6.